Hey guys, welcome back to my channel. I hope you are all doing good. Today we are going to see one more problem from lead code, that is nothing but problem number 141, detecting linked list cycle. We are given the head of the linked list and we need to determine if linked list has a cycle in it. Okay, let's see the problem statement in a diagram for a better understanding. Assume we are given one linked list like this: 1, 2, 3, 4, and force next is 2. If we carefully observe this particular input, it has a cycle, right? So in this case, we need to return true. Let's take another input. So 1, 2, 3, 4, and force next is null. If we carefully observe this particular input, it does not have any list cycle. So in this case, we need to return false. So either we need to return true or false depending upon the input. So let's see how we can solve this particular problem. So the Navi approach can be, we can use the hash map data structure here. Okay. Let's see how this particular one can help us. Assume we have an input set something like this and force next is 2. We are going to store each node, complete node, not the value. Okay, so we can store complete node here. This is my hash map. So each time I will check whether that node is already exist or it's not. If it exists, that means it already visited. So again it is visiting by another node. That means we have a cycle, right? So let's see this particular problem. So 1 is not there, so I inserted, and then I am at 2. So do we have 2 in our hash map? No. So I am going to insert 2. Then 3. Do we have 3 in our hash map? No. I am going to insert 3. Then 4. Do we have 4 in our hash map? No. Then 4 is get inserted. Then force next is 2. Then I am here. Do we have 2? Yes. So that means this particular node is visited 2 times, right? By 2 nodes. So in this case, we can conclude this linked list has a cycle and we can return straightforward true. But what are the time and space complexities with this approach? So the time complexity is going to be big O of n, because we are going to iterate through the every node of the list. So the space complexity also going to be big O of n, because we are maintaining this additional data structure, right? But if we carefully observe the problem statement, so we have some follow up, like, can you solve using big O of 1 constant memory? Okay, so as per the time complexity, this approach is good, but as per the space complexity, we can still bit optimize, right? So let's see the optimized solution for this. So we can see one example. So there are two persons. Okay, two persons, person 1, person 2. Okay, they are running across a circular track. Okay, so person 1 can run with 2x speed, person 2 can run with x speed. Okay, so if they both started at this particular point, okay, person 1, person 2. Okay, so we can observe from this diagram, at some point, let's assume this point. Okay, at some point there are chances to meet these two persons, right? Because this guy is running at 2x, this guy is running at x. So assume this is the point where they both met. So with this intuition, what we can conclude is, so if one is running with a 2x speed and other one is running at x speed, and if they are met at one point, that means it has a cycle, right? So we are going to apply the same logic to solve our problem. Let's see how we can solve this one. Okay, so this is our input: 1, 2, 3, and 4. 4's next is 2. Okay, so I am going to have a concept of slow pointer and fast pointer. Okay, slow and fast pointers. Okay, so always my fast pointer will go with 2x speed, my slow pointer will go with x speed. So if my fast is equal to slow, in that case it has a cycle, then we can return true, otherwise we can return false. Okay, so let's debug this particular input set. 1, 2, 3, 4, and 4's next is what? 2. Okay, I'm going to maintain these 2 pointers as I said. So fast I'm denoting with F, slow I'm denoting with S. So initially they both are at same position. Okay, my fast, my slow. Since my fast needs to go by 2 nodes forward, then I need to check my 2 nodes, right? So my fast is not null and its next is not null, then I can move my fast to what? 3, right? So initially it is going to be 1, they both are at 1, and then my fast move to the 3, 3, then my slow is going to move by 1 node. Okay, my slow is at here, then my fast is not null, its next also not null, then my fast is going to point where? Here, right? 2. My slow is going to point here. Okay, and once we move both the pointers, then only we do comparison. Okay, so here 2 not equals to 3, and then my fast is not null, its next also not null, then I am going to move my fast to here. Okay, and my slow is here, right? So slow is going to come here. So here we carefully observe my slow and fast pointers met. Okay, so I can conclude here this list has a cycle. Okay, if they both are not met, they both are not meeting, and force next is null, then we can simply return the false. Okay, I hope you got the intuition, and let's see time and space complexities with this approach. The time complexity is going to be go often because you are going to iterate through all the things. The space complexity is going to be big often because you are not maintaining any additional data structure to process this request. Okay, let's solve this problem. So if head is null, if head is null, return head straightforward. Let's take 2 nodes, 2 pointers I mean to say. List node fast equal to head, list node slow equal to head. Okay, while fast not equal to null and fast dot next also not equal to null. Okay, till this condition satisfy, we have to do fast equal to fast dot next. Okay, slow equal to slow dot next, and we have to do this comparison. If fast equal to slow, at any point. Then simply return true. Otherwise, at the end you can simply return false. That's all the code. Let's run it. Okay. So incompatibility. Okay. Yeah. Okay. It got run. Submit. Yes, you can see our code got submitted. Thanks for watching the video. I hope you learned something new today. Have a great